map out that there's really something there?
Yeah. Just forget that part. The phantom limb stuff, that's all true. And the blind stuff, and taking over parts of your brain, that's all true too. And the one other thing I wanted to mention is that your brain is really important, obviously. And so it has all these blood vessels, like everything in your body, but it has a whole lot of blood vessels that are redundant. So the part of your brain, if one of these blood vessels gets blocked off, that's what usually happens when you have a stroke, is one of your blood vessels gets blocked. Then there are other blood vessels that are feeding the same part of the brain to kind of cover for it. So that's because the number one thing that happens to brains is strokes. So don't smoke, get your cholesterol checked, and you'll probably increase your life by like 5 years. And you won't have a stroke, which is no fun. All right, look, we're on the third bullet point.
Yay!
All right, so now you know the brain and the spinal cord, and this other stuff's going to go faster, I promise. The peripheral nervous system is what's left. And it's divided into two parts. Somatic, is that a word that sounds familiar?
Yeah, somewhat. Can you explain, elaborate?
So soma means body, like a soma. Sometimes cell bodies are called somas in biology. Okay, soma.
Like a carcinoma.
No, carcinoma. A little different. So somatic means things that you can control. So somatic is all your sensation and all of your muscles. That's what the somatic nervous system is.
Hold on.
And it's a part of the peripheral nervous system. And so what it controls is all your kinds of touch. You have different, remember how you can't feel, how your headaches don't come from your brain, even though they feel like they're in your brain? That's because your brain doesn't have any of these guys, which are pinch receptors and poke receptors and temperature receptors and light touch receptors. And there's all these special kinds of nerves for all those different things. And so that's your somatic. And these are words that you should write down or look up. Afferent. Oh, let me go back to the slide. So you can see. And afferent. Afferent. Are those words that look familiar to anybody?
No.
Yeah, it's about as confusing as affect and effect, which always have baffled me. But what this means, the afferent nerves are arriving in the brain, or are information that's arriving, and the efferent is information that's exiting. So, yeah, exactly. It's imports and exports. So the efferent nerves are the ones that control your muscles. They're nerves that information is leaving the brain and going out to the muscles. And the afferent ones are information that's coming in from your skin and your eyes and your ears and going into the brain. Sorry, I didn't get that part yet. But it comes in from your skin and also your peripheral somatic nervous system, or peripheral somatic afferents, actually, are your taste and your sight and your smell and all that stuff. That's why your peripheral nervous system is like the most important thing. Even though you don't think of it as most important, it's the part that gives you everything in life. Like all your experience of life is from the peripheral nervous system. And it controls your muscles. You got that. The last little piece of the nervous system is the enteric nervous system, which is it's wrapped all around from your esophagus all the way through. And what it does is it controls. It's like a system all on its own. So it can function without. If you cut off, if you disconnected your head from the rest of your body, the nervous system for the rest of your body, you would still be able to digest, and if you ate something bad, you'd still throw it up, and that's and you'd still go to the bathroom normally, or no, you wouldn't. That's not true. That's not quite true. You'd still feel like you need to go to the bathroom, and you'd kind of get ready, but you wouldn't do the last step. That's because of this thing called the enteric nervous system. All right. So that's the peripheral nervous system. It had somatic part. It had a somatic part, and then it had this part, which is called the autonomic, and it works automatically. Autonomic. And it has afferents, which are, that's how you know that your stomach is upset, is the afferent autonomic. And the efferents are divided into two sections. Have you ever seen these words, sympathetic and parasympathetic?
No.
Sympathetic, all right. So so what's left over? We now can control the muscles, we can sense stuff on our skin, and I told you there's something that runs your digestion. So what we need is something, the brain controls everything. That's the number one rule. So we need some way to control the heart, the the lungs. We need to be able to poop. That's important. And pee. Those are really important things. And so that's going to be covered by this autonomic nervous system. And it's divided into two sections, the parasympathetic and the sympathetic. And the sympathetic nervous system is what you think of when you think of nervous. So when your sympathetic nervous system turns on, that's adrenaline. Oh, sorry. Geez, just shout out.
So like when you constipated, do the nerves be affected?
The enteric nerves? So yeah, when old people, as you get older, you guys we'll probably all end up in a hospital at some point because you're in the science and medicine school. Everyone in the hospital is worried that they're not having bowel movements. And like the first thing you ask every old person is, did you have a bowel movement this morning? And the reason is that your enteric nervous system gets kind of, like your central nervous system gets Alzheimer's, your enteric nervous system gets kind of the same thing. It just gets kind of lazy and confused. What's that?
You forget how.
Yeah, you forget how to move things through, and so you get a little less hungry. You forget how to move things out, and you get constipated. And that's your enteric nervous system, yeah.
What part of the brain, like the fear center, is there such thing as a fear center?
Fear center is probably the amygdala.
That's the only
It's mostly been studied in rats and dogs. And in there, it's the amygdala. You remember the amygdala? It's a little ball that's inside of the hippocampus.
Oh.
Yeah, and that's your fear center. So if you take that out, you don't fear anything. You hug everybody.
A monster gonna come to you and then you give it a hug. Hi, cutie.
Mental disorder.
What'd you say?
Okay. This is the end of it. This can be the end if you want.
No, it's not.
Okay. So mental disorders are really
I know.
cool.
You got a wow.
I'm gonna come back to that, okay? Because it's gonna make more sense when I get to my last section, which is like in 2 slides, okay? So if I don't get back to it, then you can whack me with a reflex hammer.
Alright, I will.
Good deal. All right. So this is your sympathetic nervous system. It's getting sweaty. Your pupils pop open. You stop digesting. You get ready to fight or flee. That's what it's called, kind of generally. It's the fight or flight part. It's the part that speeds up your heart rate and gets you ready to like fight. All right. Then you have the parasympathetic, which is the rest and digest part. And what it does is it slows your heart down. It turns on this is what turns on every time you have Thanksgiving dinner. So you eat that, your stomach's doing its thing, and your heart slows down. You get a little sleepy. That's the parasympathetic.
So it's almost like you're coming off a high.
So like uppers. Actually, this is interesting. So the sympathetic nervous system is what gets really tweaked when cocaine or like PCP or like those kind of uppy, speedy drugs are affecting your sympathetic nervous system. They're kind of tweaking it up a little bit. All right, now So there are cells inside your brain. They're called nerves, and this is like the coolest picture ever. And it's super fancy technology, and this guy's gonna get a Nobel Prize, whatever. What he shows is that you have these cells inside. Your whole brain is made up of these cells called neurons. What do you guys know about cells? Some smarty pants. Tell me what.
There are 2 kinds of cells, eukaryotic and prokaryotic.
That's awesome. So these are eukaryotic cells. Smarty pants. And yes, you are the smarty pants. Smart pants. And these cells you think of cells as little round guys. But cells can be all sorts of different shapes depending on what they have to do. So the cells on your skin are really thin and hardy, so that you don't bend into your chair. And the cells in your gut are really soft and they absorb things and they're kind of tall. And the cells in your nervous system have really long things coming out the top and really long things coming out the bottom. And you have 100 billion neurons, which is the same. Amazingly, it's the same as the number of fingers on the planet, living fingers on the planet, living human fingers on the planet.
How y'all know? How y'all know it's 100 billion?
That's a really good question. And they don't really know. So if you look up estimates, they're very different. Because what they do is they take a little part of the brain. So 100 billion is a lot to count, and no one could count that many. So they take a little part of the brain and they count. Oh, there are 100 neurons here, and this is only 1/1000th of the brain. Therefore, there must be about 100 billion neurons.
And some of them die.
They do. They can die and they can regenerate. So these are rough numbers. It's like an order of magnitude. It's 100 billion plus or minus 100 billion. But gonna be a test on that part. All right. This is just showing that there are different kinds of cells. So there's skin cells and there are gland cells, and this is a nerve cell. It's not. It has the big round part that you think of, and that's called the cell body or soma. Soma body, somatic nervous system, and then it has these things. It's like dendrite, and dendrite is Latin or Greek or something for a tree. So because it looks like a tree, it's like there's a tree sprouting out of this guy, and it also has this big root-like thing called the axon. All right, and the way that and they come in all sorts of different shapes and sizes. So you can have neurons that are really long and skinny. They can have really big dendrites, and they can have really branchy axons. But the basic gist is that the dendrites up at the top get all of the inputs, and then they all come together at the cell body, and then the neuron decides whether or not it wants to tell the next neuron what's going on. So there's the axon is output, the dendrites are the input, and the cell body is like this is the brain. It decides whether or not to tell the output part about the inputs. And there's also this stuff called myelin. Anyone ever heard of that?
No.
What's someone said MS. You say MS? So I'm not gonna call you. Who said MS? Multiple sclerosis. Awesome. Do you have any idea what that is? Or what happens to someone with that?
They can't control their muscles, right?
Yeah, exactly. So what happens exactly is that this myelin stuff, your body you fights your own myelin. So it dissolves the myelin, and then without the myelin, your cell body can't talk. You can't. The output tract doesn't work as well. And the reason for that is it's kind of complex. But basically, what the myelin does is it's like the insulation on a wire. And so if you ever here's something to try at home. Okay, so find a lamp and cut the insulation off of both of the wires, and then twist it. And what will happen is it will short out.
Dangerous.
That's an absolutely stupid idea. That's what happens in MS, is that the insulation falls off of the wires and they short out. All right, this is a really good test. This is the last thing that you need to understand before Dr. Chandra comes on Thursday. Because so this is the part you have to remember. The way that neurons talk to each other is that all the information comes into the soma, the cell body, and then in order to get out the axon into the output part, what you have to do is get something, you have to get above a certain threshold. So that's what this clip is for. I don't know if this is going to make a lot of sense, but each neuron has a certain amount of like excitability, which represents, I'm representing by this guy on this clip. And you can decrease the excitability or bring the guy farther from the cliff, or you can increase the excitability or get the guy closer to the cliff. And there comes a point of no return, boom, when he falls off the cliff. And that's called an action potential. And that's something you should look up and write a flashcard for, because Chandra's going to ask you about it on Thursday.
So that's when the neuron reaches highest excitability point.
What?
One more time? Yeah, neuron reaches the point of
No return.
no return, exactly. So that's called an action potential. And what happens in an action potential is that it has this electrical, no. It's called an action potential because it has the potential to make action. It has the potential to move your muscles. And here, the way it works, this is the coolest picture. Is this in your guys' physics book? I don't know, it's in my high school physics book.
No.
Obviously I did a terrible job scanning it. But this is a guy in a car getting hit by lightning. And the lightning is coming down here, and it's conducting along the car and coming off of the wheel onto the ground. And he's totally fine. That's the best part about this. And that's what happens, that's how neurons talk to each other, is you have this electrical impulse that conducts